Ladies and gentlemen, please welcome Chief Executive Officer of Amazon Web Services, Andy Jassy.
Thank you, and welcome to the 6th annual AWS reInvent. This is our very favorite time of the year. It's our favorite week, and we're really excited that you're spending the week with us. You're here with 43,000 of your peers. There's another 60,000 plus in the live stream. For those of you here, there are over 1,300 sessions you get to learn from your peers. Most of them are taught by customers and partners. But I have so much to share with you in the next 2.5 hours. I can barely contain myself. I'm going to get right to it, so let's giddy up. So I'm going to start with a quick update on the AWS business. It's an $18 billion revenue run rate business with a 42% growth rate in the last financials that we released. It's a pretty healthy clip on a reasonable sized business. We have millions of active customers. We consider an active customer a non-Amazon entity that's used the platform in the last 30 days. And it's really a broad and diverse customer group. And you can see it in the startups. Most of the successful technology startups use AWS and have built their business on top of us. And these are companies like Airbnb and Pinterest and Slack and Domo and Stripe and Robinhood and Intercom and Grail and Opendoor. And then now, over the last few years, every imaginable vertical segment in the enterprise is using AWS in a meaningful way. In financial services, it's Capital One and Intuit and FINRA and Barclays and the Commonwealth Bank of Australia. In healthcare, it's Johnson & Johnson and Bristol Myers Squibb and Merck and Cerner and Pfizer and Novartis. In oil and gas, it's Shell and BP and Hess and British Gas. In manufacturing, it's GE and Philips and Siemens and Schneider Electric. In media, Netflix and Disney and HBO and Turner and Discovery and Fox. In consumer packaged goods, companies like Kellogg's and Coca-Cola and Nestle and Unilever. In consumer electronics, Samsung, and LG and Hitachi. Every imaginable vertical business segment is now using AWS in a meaningful way. And you also see it in the public sector, where we have nearly 3,000 government agencies worldwide using AWS, about 8,000 academic institutions, and over 22,000 nonprofits. Very diverse and broad customer base. Since the very beginning of AWS, our partner ecosystem has been really strategic to us, and that's because we know that customers want help moving to the cloud, and they want to use the same software they've used on premises, but just on our technology infrastructure platform. And so we have thousands of systems integrators who've built practices on AWS, and they range from the global SIs like Accenture and Deloitte and Capgemini and Cognizant and Infosys and Wipro, CSC, to a lot of the born in the cloud SIs and regional SIs who've done a lot of the heavy lifting in the early days of the cloud. And these are companies like Slalom and Second Watch and LogicWorks and Relis and Dataluz in Brazil and CloudPack in Japan and CloudReach in the UK. And then we also have a very large ecosystem of ISVs and SaaS providers. And so what you see is that most ISVs will adapt their software to work on one technology infrastructure platform. Some will do two, very few will do three. And they all start with AWS because we're such a significant market segment leader. And so you see that across the board with companies like Acquia and Adobe and C3 IoT and Here and Heroku and Infor and Informatica and Pegasystems and Splunk and Tibco. The lion's share of the cloud workloads for Salesforce and Workday run on AWS. Much larger ISV ecosystem in AWS than you'll find anywhere else. This is Gartner's latest Magic Quadrant for infrastructure as a service. You can see once again that AWS is the clear leader in the top right. And then I thought this was an interesting analysis. This is Gartner's analysis of market segment share in this cloud computing segment. This is their last report, what they issued in September or so. And you can see AWS has 44.1% market segment share, and all the other 9 companies they evaluated on the left combined is less than half of that. So we have a very significant market segment share leadership position. And by the way, that 44% is up year over year from 39%, so it's expanding. So when the team and I think every year about this keynote, we try to think about the sentiments of what we're hearing from builders. And you've heard me talk in the past about the cloud being the new normal, or the freedoms and the superpowers that the cloud gives builders. And the theme that struck me this year is how builders are wanting to compose their applications, and how in many ways it's really similar to how music builders or musicians compose their songs. If you think about it, both want all the tools and instruments that allow them to create whatever's in their mind with whatever richness and whatever layering they want. You know, a musician doesn't want to have to use an acoustic guitar for every guitar part. Sometimes they want to use a Gibson electric guitar. Or if there's a horn part, I guess you could play the whole horn part with a trumpet, but a lot of times the parts call for a saxophone or a trombone. They don't want to be constrained, neither do technology builders. Both want the freedom to be free from abusive relationships that stop them from doing what they want. In the music industry, it's often the labels. In the technology industry, it's old guard technology providers optimizing for themselves. Both have to have conviction about their ideas because they're inventing something that wasn't there before. And people are going to doubt them, so they need conviction for those ideas, but they also need ways to check in and make sure they're steeped in reality. In this day and age, both want information about their fans or their customers so they can try to predict what they might like and deliver that. And then both, when they have an idea, don't want to have to wait to implement that idea. They're impatient to get it out there in the world. For technology builders, AWS, on all these dimensions, radically changes what's possible, not just versus all other alternatives out there today, but versus what's been possible in the past. So we're going to talk about some of these themes today during the keynote. We're going to try something a little bit different today. We have an awesome house band here on stage, and we're going to play 5 songs that have lyrics that I think capture the sentiments of what builders really want. And apart from enjoying the music, I encourage you to listen and follow the words on the screen, because we're going to talk about each of those after we get through some of those songs. So to kick us off in our musical journey, we're going to start off with the amazing, iconic Lauryn Hill. Everything is everything. After winter must come spring. So I'm going to get back to that parenthetical at the end of my presentation, but for now, let's focus on everything is everything. And when you first hear that, it might sound redundant or it might sound a little nonsensical, but if you listen to the words in Lauryn Hill's song, it's really profound. What she's saying is that people shouldn't have to suffer getting just a part of the way there when it comes to civil rights, or they shouldn't have to suffer all kinds of indignities on the way there to equality. And while I would say that technology is a lot less profound a topic than civil rights, I think Lauryn Hill's words and message applies to lots of different situations and industries, including technology. If you think about it, when you're choosing the infrastructure technology platform that you're going to build all of your applications and really your business on top of, it's an incredibly important decision. It can be the difference between whether you have a customer experience that's performant and available, whether or not you can innovate at the pace you need to, whether you can compete with other companies moving and inventing really fast. It can really relate to your survival. And when builders think about moving all their applications to a cloud and being able to build whatever they could imagine, they don't want to settle for a fraction of the functionality of the leader. They don't want to have less than their peers have, because they realize that having everything is everything. And there's nobody that has close to the functionality that AWS has. And so you can look at, I won't go through this whole architecture, but AWS, thankfully, AWS has an incredibly robust and diverse and fully featured technology infrastructure platform with over 100 services. And we have, at the bottom layer, we have 16 regions. A region for us is a place in the world where we have multiple data centers and 44 availability zones within those, with another 7 that we've announced and 17 availability zones coming. We have every imaginable form of compute, which we'll talk about a little bit later. We have object storage and block storage and archival storage and a storage gateway. We have lots of flavors of relational database, a very low latency, fast, non-relational database. We have an in-memory store with managed Redis and managed Memcached. We have a broad array of analytics offerings, a broad array of machine learning offerings, a broad array of mobile offerings. We have a lot of application services. These are services like caching and notifications and search and email. We have the only place where you can use the same software that you used the last 10 years to manage your infrastructure on premises, VMware, and run it seamlessly on top of the AWS cloud as well. We have depth and media services. You might have seen on Monday, we announced 5 new AWS Elemental media services. We have all kinds of capabilities, if you think about it, at the people level, where we have lots of account managers and professional services and solutions architects and technical account managers, and then the largest, by far, marketplace you'll find around. This is the most functional, most capable technology infrastructure platform by a lot. Not only do we have lots of services and more than you'll find elsewhere, but we're also iterating at a faster clip. Last year alone, we launched what we considered over 1,000 significant services and features. This year, we anticipate that number will be over 1,300. So the pace of innovation is continuing to expand. Not only more services, but we also have a lot more depth and features within each of those services. And I could have filled several screens of different material here, but I just chose these 6. You can look at, with storage, with block storage and object storage, as well as third-party storage partner integrations, nobody has much more than half of what AWS has. Or look at relational databases. We have 6 flavors of relational databases. We have MySQL, Postgres, MariaDB, Oracle, SQL Server, and Aurora, which is the engine we built ourselves. Nobody else has more than 2. Or you can look at serverless computing, where you want to actually be able to set up a bunch of triggers that then trigger code that you want to run. You need a lot of services that you can set triggers in. AWS has 18 of those today and counting. Nobody else has more than 6. Or you can look at key management or security and compliance capabilities. Again, you won't find others who have much more than half of what AWS has. A huge difference in functionality. This is a comment that I think kind of sums up how a lot of enterprises, particularly mainstream enterprises who are now making their move to the cloud, feel when they actually start using AWS in the cloud. And this is from an IT manager at Whirlpool, which is a traditional mainstream enterprise that's traditionally been an IBM shop. And here's what he said recently. He said, "I can't express how exciting it has been the last week to have a service and platform that creates demand. We were talking through AWS storage solutions with an internal team, and they kept asking questions, and we kept getting to say yes. Encryption? Yes. Customer encryption keys? Yes. PCI compliant? Yes. Lifecycle rules? Yes. Will it save us money? Yes. How long will it take? Give me a week." Then they said, "Oh, we can't move that fast. We need it in 2 months." No problem. This is the type of enablement you get when you move to a platform that has this type of capability like AWS. To share a little bit about how they're using the breadth and depth of AWS's platform, and it's been a big part of leading to their deciding to go all in with AWS, it's my pleasure to introduce to the stage the CEO of Expedia, Mark Okerstrom.
All right, well, hello, reInvent, and thank you, Andy. It's wonderful to be here. So how many people here have heard of Expedia? Yes, Expedia, it's all about travel, right? Well, underneath the veneer, it's actually all about tech. Expedia is actually one of the largest global e-commerce tech companies in the world with over 22,000 employees and nearly $90 billion in gross travel sales. We operate an incredible portfolio of the world's leading travel brands. I know you're leaning over beside you and saying, "I didn't know they owned that." I'll let you know a little bit of secret. But underneath those brands is an incredibly powerful platform. Platform, you say, Mark? Now I've got your interest, don't I? Yes, Expedia is actually the largest, most global, diversified travel platform in the world. Every month, 600 million visits come and hit our websites around the world. Over 1.6 million corporate travelers use our platform. We handle over 55 million phone calls every year in over 40 different languages. That's a lot of people. That's a lot of people going to a lot of places, and our job is to connect those people with the vast and diverse array of travel service providers that are also on our platform. We're the only global platform that can literally take any person from any place to any place by almost any means. We call ourselves a travel company or a tech company. In reality, we're a people logistics company. Now, you'd imagine a platform like that has some pretty impressive stats, and we've got some pretty impressive stats. If you look at daily search volume from external users, if you take a look at the number of inventory and pricing calculations, the number of automated, translated, generated words we do, some of the numbers are absolutely staggering. But of course, we didn't get there overnight, and of course, we were not born in the cloud. We started in 1996 as a small division within Microsoft and have since gone through a series of reinventions. 2009, we started a massive replatforming effort to essentially rewrite every line of code. Recently, we retired our 10 millionth line of C++ code. Pretty remarkable. So now we're on this next journey of reinvention, which is reinventing into the cloud. And we sit here with about 45,000 servers, about 35 petabytes of data, over $600 million of physical assets in our data centers. And we think about it, it's kind of like swapping out the engines, the navigation system, probably the interiors of a 747 at 40,000 feet over the Atlantic. But we are absolutely up for it, because in essence, Expedia, me and the 10 other Expedians who are speaking at this event, can represent ourselves as, in fact, serial reinventors. We started with AWS testing in the true Expedia way of test and learn in 2012, and over the course of the last 5 years have created increased confidence that this is absolutely the right move. And we've set some really bold goals. Within the next 2 to 3 years, we'll have 80% of our mission-critical apps in AWS, and we're making some serious financial commitments. We spent over $100 million this year. Next year will be north of 150. So why would we possibly do this? Why? Well, 3 important reasons: resiliency, optimization, and performance. Let's talk about resiliency for a second. Who likes these 2 words, disaster recovery? Yes, who is involved in these exercises? Well, Expedia, these things are done with military precision. Every second mapped out, knock calls on the bridge hourly, pizza for everyone at 2 a.m. But that increasingly is looking like the past. Very recently, earlier this year, we had a taste of the future. Our flagship site, Expedia.com, which takes over 100 million hits a day, was experiencing some challenges. Within hours, we rolled the whole front end up into AWS. No issues, no preserved customer latency, no pizza required. So the future for disaster recovery for us is about always on with AWS. Let's talk about optimization. Optimization for us has come in the form of developer empowerment. Our engineers used to write code, pass it off to test, pass it off to DevOps. Somewhere in there, someone would call the data center guys and say, I need 10 boxes. Better make that 30. I know you did that. I used to be the CFO. Today, it's completely different. Our engineers have end-to-end autonomy, end-to-end accountability. They're building, they're deploying, they're optimized. You give an engineer immediate feedback and a goal, boy, they do amazing things. Our engineers have already saved us millions this year just by writing more efficient code. You talk about performance, whether it's the fact that we spend over $500 million in marketing algorithmically and are now actually processing real time, whether it's the fact that our engineers are now deploying code 2,000 times per day, over 4,000 cloud-native apps. We've essentially been able to take the innovation curve and actually stand it on its tail, and we're super excited about what comes next. Whether it's customer experience, the fact that we've improved site performance for our Asian customers by over 4x. Performance is remarkable. And we really put it to test a couple of years ago. We took this guy, the gnome, Remember the gnome? This is a site that has millions of hits a day. And within 91 business days, we took it off of its existing infrastructure and migrated onto the brand Expedia platform. How did we do it? With near infinite traffic routing, scalability, and AWS. In fact, it changed the way we thought about acquisition integrations, and since Travelocity, we've done several more to huge success. Of course, AWS started as a data center outsourcer, but since that, it's become this incredible ecosystem of services. If you talk to the Expedians, we're probably using most of these. Thank you for giving back to the ecosystem. But of course, none of this really matters for Expedia unless we're delivering on our core mission. We are incredibly passionate about being customer-centric. For us, it's getting closer to absolute personalization, being able to deliver to you, the perfect set of travel search results for when you're going and what you want to do. We're scoring over 300,000 hotels every second, increasingly taking more personalized data to actually get you the perfect results, and handling nearly 18 million images, over 35 terabytes of data in AWS. We're able to serve up the perfect image to help you make the perfect choice nearly instant. We're also very passionate about being locally relevant in every market in which we operate. Our Malaysian customers need to have perfect translation. We need to have all the local places, all the local hotels, and it needs to be fast. By moving our code closer to our customer, our Malaysian customers are getting absolutely that. But let me take it up a notch. In this crazy world of ours, we're probably more interconnected than we've ever been. But if you read the news like I do, it seems like we're drifting further apart. What's the solution? Well, there's a hint in something that Mark Twain once said, which is travel is fatal to bigotry, prejudice, and narrow-mindedness. Therein lies the fact that if we can physically connect with each other, understand each other's cultures, we can make this world a better place. As the world's largest travel platform and the only place that connects anyone to any place via any means, Expedia has an incredible responsibility to the world. It's something we take seriously, it's something we're humbled by, but it's something that we are incredibly energized by. And we are absolutely thrilled to have AWS alongside us each step of the way. Thank you.
Thank you, Mark. That was awesome. It is really an honor to work with Expedia, and we've learned a lot from the relationship, and we're looking forward to what we're working on together. And they have a huge mission and a lot of passion, as you can see. So, as you heard a little bit from Mark, I mean, their mission is broad, and the breadth and the depth of what AWS provides is enabling them to fulfill that mission. And so I thought we'd talk a little bit more about what that means to have that kind of depth. And I could kind of, again, we could look at every single area in the infrastructure technology stack and give examples of how this exists. But let's take compute as an example. And if you look at compute, the three main ways that people use compute are they use EC2 instances, they use containers, and they use what people call serverless, which is really function as a service. Let's go through each of them. Let's start with instances. So you will find with AWS that we have meaningfully more instance families than anybody else. And that really matters for builders because your applications have different constraints. And so we have instance families that suit you whether your applications are compute constrained, or memory constrained, or storage constrained, or I/O constrained, or if you have big data workloads, you can see the new H1 instances we launched last night, which are perfect for those. If you need to get at the hardware, but you still want the elasticity and the reliability and the scalability of AWS, we now have bare metal instances that we announced last night. If you need GPU, we have the most powerful GPU instances out there in P3 instances. And if you want an FPGA instance, we have that too. So it's that broad array of instances. And then what we do is we make all of our excess capacity at any one point available to you in a spot market. And if you have applications that can afford to be interrupted and be intermittent, where you use the capacity when it's available and you don't when it's not, And Spot allows you to save about 90% on the price of on-demand instances, which is really useful. We have a huge Spot market. And then we found that we had a lot of customers that wanted to be able to add GPU to their instances, but not have to pay for a full GPU instance, which is much more expensive. So with elastic GPUs, we give you the ability to add a little bit of GPU to any instance type that we have. This is a much broader capability across instances than you'll find elsewhere. How about containers? More and more people are running containers over the last couple of years, in part because you can deploy in smaller chunks, and as people are building in a microservices architecture, you can encapsulate those microservices in containers, and they're easier to move around. And when we started working on a container service back in 2014, and we launched the Elastic Container Service, or ECS, at that time, there really wasn't any broadly adopted orchestration and management system for containers. And when people asked us for a container, they said, we don't just want a container. We want something that is deeply integrated with the rest of the AWS platform. We want all the same capabilities that EC2 instances have. And so that's why we built ECS. And people really like ECS. We have lots of customers using it. And there are a few reasons. First of all, because we built it from the ground up to be deeply integrated with the platform, it means it integrates with all the capabilities on the platform. And you can see a lot of those services up there that it integrates with. It also scales in a much broader way than you'll find with other container services. So if you think about Expedia, they need to scale tens of thousands of containers to run their apps. And all the other container services don't scale to that level of nodes that you have to scale to. And so you need something that, as big as you get, if you want to run something mission critical in production that really scales big like ECS does. And then, because we control ECS and we own ECS and we're building ECS, we can do container level integration with everything that we do. So for instance, when we launched our application load balancer or our network load balancer, they launched right from the get-go integrated with ECS, which is very compelling for people. And we have lots of customers, not surprisingly, using ECS. At this point, we have over 100,000 active clusters or containers at any one point. And every week, hundreds of millions of containers are being launched. And we have lots of customers running them that range from Capital One and Mapbox and GoPro and McDonald's. But over the last 18 to 24 months, lots of people have become interested in Kubernetes. And if you think about it, Kubernetes, the resonance there is very high, and the majority of Kubernetes that runs on the cloud today runs on top of AWS. So, a recent CNCF survey that they did showed that 63% of the Kubernetes that's running in the cloud is running on AWS. And yet, for customers who want to run Kubernetes on top of AWS, there's work to do. You have to deploy a Kubernetes master and Kubernetes workers, and then you have to, if you want high availability, you have to do that across multiple availability zones, and you have to configure them to talk to each other and load balance and fail over. It's just work. And so our customers said, well, it's great that we're running Kubernetes on top of AWS, but is there something you can do to make that much easier to run? So today I'm excited to announce a new service called the Amazon Elastic Container Service for Kubernetes, EKS. This makes running Kubernetes as a managed service on top of AWS much easier. And I think there are several things that you guys are going to like about this. The first thing is, it's just the latest version of Kubernetes, so it'll integrate and work well with everything you have and what you're running on premises. Second thing, and this is really compelling, is that EKS will automatically deploy Kubernetes masters across multiple availability zones, so you don't have a single point of failure. This is really different than the other managed Kubernetes services out there that really deploy only to one availability zone, so you do have a single point of failure. It's a big deal for people if you care about availability. It also has the capability to do automatic patches and upgrades, but it gives you a lot of control over when you do those. And then EKS is integrated with a lot of key AWS features. Now, we're working hard with CNCF and the community to make changes to allow it to be integrated with all of the key capabilities that ECS is, and we're going to work really hard on that moving forward. So we're really excited about EKS. And now you've got 2 managed containers that you can choose from, ECS and EKS. And people are excited about that, but what we've heard from customers is managed containers makes our life much, much easier. Thank you very much. However, there's always a however. It would be great if we could run containers without having to worry about servers or clusters of these things. We thought, okay, well, we thought managed containers were pretty good, but that's interesting, running containers without managing servers. So we thought about that as a team. It's a tricky problem. We worked on that for the last year, and I'm excited to announce a new capability called AWS Fargate, which allows you to run containers without having to manage servers or clusters. So Fargate is really simple to use. You just package your application into tasks, which people are used to doing. You get to manage this at the task level. You specify the CPU and the memory you need. You define the network and the identity access management that you're going to need. And then you upload everything to Fargate, and Fargate deploys those tasks for you and then automatically scales it out across multiple availability zones. It'll auto-scale for you, so there's no servers, no clusters, no provisioning. It sets up all the surrounding infrastructure you need to be able to run this thing really hands off the wheel. It totally changes the way that you can run containers. People want to run containers at the task level if they can instead of the server level. And Fargate radically changes how you can now run containers. Very excited about this. Let's talk about serverless. So if you think about it, 3 years ago, AWS pioneered this event-driven serverless computing space with the launch of Lambda. And what Lambda lets you do is it lets you upload some code through the AWS Management Console, set triggers, and when those triggers are met, it runs that code. And so you don't have to think about servers, you don't have to think about clusters, you don't have to think about auto-scaling. It's all done for you. But when you think about how many customers today are running Lambda, it's kind of astonishing. I mean, it was just a few years ago that we launched the concept, and it was a brand new concept. Today, there are hundreds of thousands of customers running Lambda today. The growth is 300% year over year, so it's pretty amazing. Again, you see lots of companies you may have heard of, like FINRA and Thomson Reuters and Fannie Mae, and it's clear that this is not just a fad. The growth in Lambda is showing people that many want to go right to the serverless step and not have to think about servers and clusters at all. When you think about serverless computing, it's not just function as a service, which Lambda is. That's really important, but if you want to run an application end-to-end that's serverless, you need other capabilities. You're going to need a service that helps you create APIs to connect to all the other services you want to communicate with and set triggers and take action on. And you can use API Gateway for that. Or if you're running a full serverless app with all these triggers and all these functions and all these actions taken, you want something to orchestrate all that. And you can use AWS Step Functions for that. Or if you want to know what's happening at various spots of your app, because there's so many things that have to orchestrate, you can use X-Ray for that. So it's not just function as a service, it's all those other capabilities that allow you to run an application end-to-end. And then, of course, you want to be able to set triggers on lots of services so that you can take action on lots of services and have really a fully functional serverless app. We have 18 of those services you can set triggers, and as I said earlier, nobody else has more than a third of those. And because event-driven serverless compute is so generally useful everywhere, if you needed one more proof point, look at all the places that we've now embedded Lambda and people are using it. In most IoT implementations, Lambda is the key driver of what action you take. You see it now in Greengrass, which is our software module we embed in devices that allow you to have the same Lambda programming model on device as you have in the cloud. You see them in Snowballs when people are actually collecting data and want to take action quickly on some of that data they're receiving right on the device itself. You see it even in our CloudFront content distribution network where people want to run functions right at the edge, at Lambda at the edge. It's everywhere. That's what you really need if you want to have end-to-end serverless. So when you think about what compute is, lots of companies, lots of folks say, yeah, I've got compute. But compute is not just having a few instance families. It's having that broad array of instance families that is unmatched, and I showed you earlier. It's being able to take all your excess capacity at any one point and make it available to customers so they can save money if they can have applications that can use those workloads that are interrupted intermittently. It's about being able to take any instance that you have and increment it with a little bit of GPU. If you're going to have a container, it's not about having one container service. It's about giving people a choice of container services. They can either choose the container service that's most deeply integrated with AWS and ECS, or if they want the open source alternative in Kubernetes, they can run both of those as managed container services. And you'll be able to take either choice there and run it using Fargate without having to manage servers at the task level. And Fargate will work for ECS right from the get-go and for EKS in 2018. And then it's not just having function as a service. It's about having all those other capabilities and all those other services that you can trigger functions that give you that full serverless capability. And then, if you want to be able, regardless of which compute form you choose to use of those 3 macro layers, you want to be able to run that compute with all the other capabilities in the AWS platform that you normally run compute with. Things like tagging and identity and access management, and having an auditable cloud trail, or seeing every API access to anything that you're running, or Private Link, which we announced last night, which allow you to connect within your VPC to any third-party SaaS application, or even within different organizations and accounts within your own company. Being able to run the VMware software that you've used the last 10 years on premises, on AWS's technology infrastructure platform, manage network address translation. All of these capabilities are incredibly important when you're running compute. Many of these we're the only ones that have. Several of them, we just have a lot more features within those capabilities. But this is the bar for compute. This is what builders want. Because you don't have to pay for any of these features up front, you only pay for what you use, builders don't want to have to settle for less of the functionality than everybody else has, because they realize that having everything is everything. So let's talk a second about freedom. You've heard us talk about freedom over the last few years. You've probably seen me tweet about it occasionally. And freedom is not only having all of the capabilities that allow you to build anything you want, like we just talked about, but it's also the ability not to be locked into abusive or onerous relationships or one-size-fits-all characterizations or tools. And to share a little bit about what that really means, let's come back to the house band and listen to what they and George Michael have to say about that. I don't belong to you, and you don't belong to me. I like those words. I think that's what builders really want. And I think they especially want it in the database space. And if you think about it, the last 20 years have been a very uncomfortable, unpleasant place for most companies with the database providers they've had to use. These are companies that are very expensive, that have high lock-in, are proprietary, and really are abusive to their customers. These are folks that don't care very much about their customers. You can just see earlier this year, Oracle overnight doubled the price of their software to run on AWS and on Microsoft. Who does that to their customers? Somebody who doesn't care about their customers. Somebody who views customers as a means to their financial ends. And it's why customers are trying to move as fast as they can to the open engines. These are engines like MySQL and Postgres and MariaDB. But to get the same type of performance on those open engines that you get on the commercial grade databases, it's possible, but it's hard, and it takes work, and it takes tuning. We've done a lot of it. It's not easy to do. And so customers asked us to try and thread that needle for them. They wanted the performance of commercial grade databases with the pricing and the friendliness of the open engines. And so that's why we spent a few years building Amazon Aurora, which is our own database engine, which is fully MySQL and Postgres compatible. It has several times the performance of the highest end implementations of Postgres and MySQL. It has at least as much durability and availability as the commercial-grade database engines, but is 1/10 of the price. It is the fastest growing service in the history of AWS, and it remains so. And you can kind of see it with the customer momentum. So a couple years ago, we were here at reInvent, and we talked about the start of this huge momentum for Aurora, and we talked about companies like Yahoo and Earth Networks and NBC Universal that were using it. Last year, we came and we explained that we had 3.5 times the number of customers using Aurora at that point, and companies like Netflix and Redfin and LexisNexis and Ticketmaster were now using it. This year, another 2.5 times that number of customers are running Aurora, and that list expands to companies like FINRA and Expedia and Verizon and CBS Interactive and Dow Jones and Hulu. Lots of customers running on Aurora, people very excited about it. And there are a lot of things that people like about Aurora. One of the biggest things that people love is the high performance and the high availability they get from Aurora. And it's very much because of the scale-out architecture that we have. So customers can scale out lots of read replicas, up to 15 read replicas. And in fact, it allows them to run millions of database reads per second with that scale-out capability. Earlier this year, we gave you the capability to auto-scale, so you don't have to figure out when you want to expand the replicas. We can do that for you. Customers love that architecture. When a read fails, it just fails over, and it fails over in less than a second, so there's no interruption to your application at all. And while customers love that, they said, you know, it would really be awesome if you guys would consider doing the same thing with writes. You know, today we have a single master for writes, and if there's a failure, we promote a read replica, and that happens in less than 30 seconds, which is pretty great for most databases. But people said, gosh, could you still try and find a way to make it as seamless as you have it for reads? So the team has worked on that, and I'm excited to announce the preview of Aurora Multi-Master, which is a scale out for both reads and writes. And so with Aurora Multi-Master, it creates multiple reads and writes and master nodes across multiple availability zones. It means it allows your applications to transparently tolerate failure of any of these masters, or even an entire availability zone. And if one of your writes fails now, instead of the about 30 seconds, it'll fail in 100 milliseconds. It'll have completely no impact to your application. It becomes the first relational database service with scale out across multiple data centers. You can see, even with Oracle RAC, the advice and the base implementation is that you're confined to a single room within a single availability zone or data center. Multi-Master Aurora scales out reads and writes across multiple data centers. And then you also, because it's a true relational database that's SQL compliant, you don't have to rewrite your applications with some kind of proprietary language. We are opening the preview today for single region multi-master. We will add multi-region multi-master in 2018. So let's look at the other end of the spectrum. So we have a lot of customers who say, I love Aurora, I want to be able to use Aurora, but here's one of my problems. I have a number of databases that are not fully occupied. You know, they may be dev and test databases, they may have a spike at the same time every day, they may have a few intermittent spikes. And today, my alternatives are, I have to buy software, put it on a machine, and run it all the time, which is paying full price for both the software and the machine. Or I can use a managed service like Aurora, but again, I'm paying for that database instance the entire time, regardless of how busy it is or isn't. And customers said, well, is there a way that we can use Aurora, but also only pay for what we use? So again, the team went back and thought about this. It's not a simple problem, I might add. And I'm excited to announce the preview of Aurora Serverless. Which is on-demand, auto-scaling, serverless Aurora. And so what you get here is you get all the capabilities of Aurora. It doesn't require you to provision any database instances. It automatically scales up when your database is busy, scales back down when it's not, It starts up on demand and shuts down when it's not in use at all, and you pay only by the second when your database is being used. That is pretty different. So let's look at the evolution of databases over the last number of years. And I think that over the last couple decades, people have largely used relational databases for everything. You know, ERP and CRM and e-commerce applications have used relational databases because they've needed those transactional capabilities. Most of the databases store gigabytes of data, and relational databases work pretty well for most things. But in this day and age, where it's so much less expensive and so much easier now to store data, especially with the cloud, most of these databases now aren't gigabytes, they're terabytes, and sometimes petabytes and exabytes. And when you get into those layers and those amounts of storage in a database, relational don't work nearly as well. They kind of break down. And so what you've seen over the last number of years is when you have these applications that have millions of users that need to do these fast lookups, they really want a key value database or a document store. And that's why we built DynamoDB. And just to give you an example, the type of scale for DynamoDB, in Amazon Prime Day, which was our biggest retail day in the history of the company back in July of this year, it was about 30 hours. At the linchpin of Prime Day was DynamoDB. And during those 30 hours, it processed 3.34 trillion requests and peaked at 12.9 million requests per second. This is unusual scale. We have a lot of customers who very successfully run Mongo and Cassandra on top of AWS. But when you get into the really high scale levels, they very often want something that's more managed like DynamoDB. Also, what you've seen over the last number of years is lots of people want to use an in-memory database. You have a cache where they can access data in microseconds. And that's why we built Elasticache, which today is really primarily managed Redis and managed Memcached. Now, if you looked at DynamoDB, if you go back a second to DynamoDB, as I mentioned, what we're starting to see is as customers are deciding they want those fast lookups in non-relational databases and they want a key value store, they're turning to DynamoDB. And you can see the list of customers here is pretty astonishing. And the growth, particularly over the last 12 to 18 months, is pretty amazing. And you see companies like Snap and Lyft and Tinder and Redfin and Comcast and Under Armour and BMW and Toyota all leveraging DynamoDB in a very expansive way. Now, today, DynamoDB already allows you to replicate your tables within a region, and multiple availability zones within a region. But customers are very interested in being able to replicate those tables across multiple regions. And that's because, you know, if you think about it, think about Expedia. They want a user that's using their mobile app in North America to have the same customer experience and latency when they use that mobile app in Europe. And that's, you know, today you can replicate globally in DynamoDB, but it's a lot of work. And a lot of people don't do it because it's a lot of work. And so I'm excited to announce today the launch of DynamoDB Global Tables. Which becomes the first fully managed multi-master, multi-region database in the world. And so global tables, it's pretty exciting. Now your data is replicated across multiple regions. It means that you can benefit from the same low latency in every region that you decide to deploy it in. As I mentioned, it's especially important for customers who have global end users who want the same customer experience. It's really simple to set up. It's just a few clicks that you have to do. You now, with the ability to have global tables, you can now withstand an outage in an entire region. So it's huge reliability capabilities it also gives you, and this is generally available for you today. What about backups? So if you think about DynamoDB, people love the availability, they love the low latency, they love the high throughput. Now they love the fact that they can deploy their global tables in lots of regions simultaneously for that reliability and that customer experience. But you need to back up your data too. And again, we have customers who've been doing this for a long period of time with DynamoDB because they have to, but it's been much more difficult than they've wanted. And so the team has worked really hard on this, and I'm excited to announce today the launch of DynamoDB Backup and Restore. So this will allow you to do on-demand continuous backups. You can instantaneously back up everything in your database. You won't find that capability anywhere else. And then you'll also be able to do point-in-time restore up to the second for the last 35 days. Again, capability that's really important if you have some kind of application error or corruption of your data. You can back up hundreds of terabytes of data that are serving large applications with single millisecond digit latency. And you can do so without any interruption to your application. This is, again, something you won't find anywhere else. On-demand backups is generally available today, and point-in-time restore is coming in early 2018. So we talked about relational databases, and we talked about key-value stores and in-memory databases. What about highly connected data? So if you think about it, there are applications. Take an application like a restaurant recommendation application, where you actually want to be able to recommend restaurants of a certain cuisine, say something like sushi, in a city like New York, that at least 2 of the user's friends liked. Well, to be able to do that, it's a lot of connected databases that you need to put together. You need to know who the users are. You need to know who their friends are. You need to know what their likes are. You need to know the restaurants. You need to know the restaurants in New York. You need to know the different cuisines or categories of restaurants. It's a lot of connected data. And you can, if you think about it, you can perform this lots of ways. But most of the ways that people are doing this today is not working very well. So the 2 ways that we see people attacking this is, first, a lot of people are trying to do this with relational databases. The problem is, in the relational model, when you try and represent the data this way, you end up with multiple tables, with multiple foreign keys, and very quickly your queries break down and slow down and become unwieldy. Or a lot of people are trying to solve this with either open source or commercially licensed graph databases. The problem is, with the open opportunities, it's really hard to get the availability that you want, and it's really hard to get the scalability that you want. And then with the commercial options, they're either too expensive, or they make you make choices like, do I want to use the property graph, like Apache Tinkerpop, or do I want to use the RDF graph model? And a lot of times, people don't want to choose one. It depends on the application. So what people really want is they want a fully managed graph database that's fast, that's reliable, that's scalable, that doesn't force them into one-size-fits-all choices. And that's why we're excited to announce today the launch of Amazon Neptune, which is a fully managed graph database. So Neptune gives developers a lot of flexibility. It supports both the property model in Tinkerpop and the RDF graph model. It's really fast and scalable. And it allows you to store billions of relationships and query them with millisecond latency. It's really reliable. So what we do is we will make 6 replicas of your data across 3 different availability zones and continually back up to S3. And then it's really easy to actually use and to query. We support both Gremlin and Sparkle. So this is available in preview today, and we're excited to see what you do with it. So if you think about it, the landscape of how people use databases today is really different from what's been the case over the last number of years. You don't use relational databases for every application. That ship has sailed. Modern companies that use modern technology are not only going to use multiple types of databases in all their applications, but many are going to use multiple types of databases in a single application. And there's nobody that provides the capability and breadth of selection in databases that AWS has. So let's think about what we've talked about so far. We talked about how builders want all the capabilities that are out there so they can build whatever they can imagine. And we've talked about how builders also want to be free from onerous and abusive relationships or one-size-fits-all solutions. I think another thing that you see with builders is that when they have a brand new idea or invention, they need to have conviction for that idea. And yet, they also have to have ways of trying to figure out whether they're steeped in reality with this new idea. It's a really interesting and hard balance in almost everything, including business. So let's see what our house band and one of my very favorite bands, the Foo Fighters, have to say about that balance. This, I think, is one of the most interesting balances when you think about new ideas, having blind faith but no false hope. And if you think about it, as an inventor, whether you're Dave Grohl and the Foo Fighters inventing Congregation, that song, or whether it's all of you inventing all of the customer experiences that you're building, you have to have conviction in your idea. If you're inventing that's something new, you don't know if it's going to work or not. And along the way, I promise you, you're going to have lots of people doubting you. I've lived through so many of those. And if you don't have that conviction, great ideas die on the vine. And I have seen so many great ideas die on the vine because builders haven't had that conviction. And yet, it's really important, in addition to having that conviction and blind faith about your idea, that you have ways to get customer feedback so you make sure that you're steeped in reality. Now, one way you can do it, you can ask customers, and that actually we find incredibly useful. It drives a lot of our behavior in AWS. But when you're doing it across the scale that all of us are doing it, it isn't the most scalable way to do it. And so the most scalable way to do it is to have great analytics. And there's nobody that has the set of analytics that you'll find in AWS. And there's a lot of things that really matter when you look at analytics solutions, starting with a data lake. So what's happened over the last number of years, as customers have accumulated so much data, and a lot of that data lives in different silos, is that it's really hard to do analytics having to go to all those different data silos. So people want to pull that data together in a data lake. And by far the most popular data lake today is S3. And there's a number of reasons why people consider S3 the best solution for a data lake. First of all, if you look at the operational performance and availability and reliability over the 11.5 years that S3 has been around, you just won't find anything like it. And there's a lot of things that we do to make that possible. We'll replicate your objects across multiple availability zones in a region, which nobody else does. And if you want to do cross-region replication, you can do it right from your current storage classes, and you can pick which regions, as many as you want, which nobody else does. It's also more secure. It's got more security capabilities. And so, it's the only storage service that lets you see every API access to every data event. It also is the only storage service that allows you to use something like Macy, which uses machine learning to classify your data into different categories, and then will let you know if there's any anomalous movement or activity to that data. It's also the only storage service that lets you operate at a fine-grained level, at the object level. The other storage services make you operate only at the bucket level. And the reason it's so useful to operate at the object level is you can set tags, editable tags, by the way, and you can do almost anything. You can tier those objects to move into lower cost storage tier, so you can set access control policies and security policies. It's the only storage service that automatically looks at all of your storage access patterns and then does analytics for you and suggests which objects you should move to a lower cost storage tier. There are more ways to ingest data into S3 than anywhere else that range from Snowball and Snowball Edge and Snowmobile and Kinesis Firehose and S3 Transfer Acceleration and Storage Gateway. And then, like I said earlier, nobody has even half of the third-party storage partner integrations that S3 has. This is why so many people are using S3 as their data lake. And you can see that if you look at Gartner's most recent Magic Quadrant for storage in the cloud, AWS is the clear leader in that top right, and everybody else is congregated kind of towards the middle. But it's not just having a great data lake that makes great analytics. You need a really broad and diverse set of analytics services. And again, you won't find anybody out here that has this collection of storage capabilities. So if you want to do ad hoc querying on unstructured data for things like log analytics or clickstream data, you can use Athena. If you want to process vast amounts of unstructured data across dynamically scalable clusters using popular distributed frameworks like Spark and Hadoop and Presto and Pig and Hive and Yarn, we have 16 of these managed frameworks, you can use EMR. If you have complex queries on structured data where you want super fast querying results locally, and you want something like a data warehouse, we have Redshift, which is one of our fastest growing services in the history of AWS. If you want to do real-time operational dashboards, you can use Elasticsearch, and our managed Elasticsearch is growing like crazy. If you want to do real-time processing of streaming data, you can use Kinesis, and that has become one of the linchpins in all IoT applications. If you want beautiful visualizations and business intelligence, you can use QuickSight. And then, of course, often the underrated part of all these analytics offerings is the service and the capability of doing ETL, which really hasn't existed in the cloud until we launched Glue about a year ago. And that will not only do the ETL, but also move your data from place to place so you can actually congregate it in an intelligent and an efficient manner. So these are the types of capabilities that you want in an analytics platform. And it's part of why you see more analytics being done in AWS by a large amount than anywhere else. You see companies like Pinterest and Philips and 3M and NTT Docomo and GE, lots and lots of companies running analytics workloads in AWS. One of our analytics customers is Goldman Sachs. One of the things I'm always amazed by is people don't realize how unbelievably technically sophisticated the big and successful and leading financial services companies are. And that is especially true of Goldman Sachs. It's my pleasure to introduce to the stage to share with you how they're using AWS, the Managing Director, Roy Joseph.
Thank you very much, Andy. It's a delight to be here, and good morning, everyone. When you think of Goldman Sachs, you most likely don't think of innovation. True, we've been around since 1869, almost 150 years. But when you think of us, we have about 33,000 employees around the world, and over 1 in 4 of those employees are in engineering. And those engineers have written 1.5 billion lines of code and over 7,000 applications, using over 200,000 servers in a cloud environment and 1.2 million cores. I hope this gives you a sense of how vibrant the technology culture is at Goldman Sachs and how much engineering we do to drive our business. Today, technology is resulting in rapid change to the financial services industry, in how we serve clients, in new offerings, and in opening up completely new business opportunities. And we believe that in order to be a leader and win, you need strong engineering, risk management, and distribution. On risk management, we aim to get the right information into our clients' hands so they can make the best possible financial decisions. And on distribution, understandably, when you think of Goldman Sachs, you think of an organization that serves large institutional customers. And that is true. However, we are looking to expand our capabilities and move into services and markets we've never been a part of before. We build, we innovate, and we enable our businesses to react to our customer needs in an unparalleled way. So let me share 3 examples with you. One to grow our revenues and expand our distribution. Despite not having branches on street corners, we moved into the retail segment by launching a consumer lending business called Marcus, named after one of the founders of Goldman Sachs. Marcus was built in just 12 months, completely underpinned by technology. And in 1 year, we have over $2 billion of loans with loan sizes of $30,000 or less. Many of our customers are using these loans to pay off high-interest credit card debt. This is a completely new business for Goldman Sachs. 2, to enable our clients, we use our core IP and web engineering to build a new digital business called Marquee. Marquee gives our clients direct access to our ideas, risk metrics, analytics, and liquidity. And 3, innovation to advance the financial services industry. We saw a need for a web-based cloud content sharing platform, which eventually became Symphony. We initially built this platform for internal use, but realized quite quickly that this could be even more powerful as an interbank platform. So we created an industry consortium to bring it to the market as an independent company. Now, 250,000 is on Symphony. So what is a consistent theme with all these 3? It shows how Goldman Sachs is leveraging its core strengths of risk management and technology to drive innovation, shape the industry, and expand our distribution. So one may ask, with that success, why the public cloud? Well, as our businesses continue to grow and evolve, we need to manage more risk. And that need drives a requirement for more computing power. A few years ago, we would have addressed that need by adding a field to one of our data centers. The inflection point had come for us at Goldman to make a real move into the public cloud. We wanted the flexibility, scaling, and innovation curve that the public cloud offered. However, there were some very real barriers for us to overcome. Several years ago, we developed a cloud management platform with a common operational model that managed our entire global compute footprint. And we wanted to expand that platform to the public cloud. So we built APIs to extend our control framework into the public cloud. But the real showstopper was data privacy. We are incredibly careful about our clients' data. This is central to every technology decision we make. If we were to somehow compromise that trust, not only would we lose our clients' confidence, but we may potentially face regulatory penalties, and that brand and reputation we've built over the last 148 years will be at risk. None of this was palatable to Goldman Sachs. So we needed a partner who could help us overcome these barriers. And believe me, this was not an easy sell internally. We need someone who was an industry leader, someone who had built new businesses, someone who had a track record of innovation, and someone who excelled at execution. And that is why we chose AWS. Now, before we could move anything to the public cloud, we had to be comfortable that our sensitive data sitting at a third-party location would be secure. And even though we trust the partner that we choose to work with, we could not get comfortable without us still having control. Think of it, this is like you having a safety deposit box at the bank. You may trust the bank to hold your valuables because they have security guards and doors and vaults, but in the end, you want to have your own key for access. We explained our problem to AWS, and immediately they sprung into action, partnering with us to define the requirement for a bring your own key, BYOK architecture. Now, some of the really great things we got out of AWS's BYOK solution were immediate detection of anomalous behavior, greater transparency into AWS's operational model, Now remember, this was new to us, and having a real-time indicator and historical logs allowed us to apply the trust but verify model to key management. And by the way, having BYOK natively in AWS also simplified our stack. It allowed us to have fewer external components, leading to less complexity, lower latency, and easier troubleshooting. Let's talk a little bit about our working with AWS. The AWS team was a pleasure to work with. Even though they were on the West Coast, we felt like they were in the same room on the East Coast with us. The engagement was iterative, and they treated our concerns and requests with a sense of urgency. And AWS's flexibility, innovation, and collaboration in providing a solution helped us to leap over a huge hurdle to take advantage of the public cloud. Now, this BYOK solution is not just good for Goldman. It's applicable to many industries and for any size customer that wants an additional level of data protection. And by the way, AWS rolled out BYOK as part of their KMS solution in August of last year. And they're actively working to integrate KMS broadly across their product line. This will further open the door for us to expand beyond core computing into many of the advanced services that you heard Andy speaking about earlier. So, what's next for Goldman? The success of having critical workloads in AWS will accelerate us in pushing other kinds of applications beyond core compute into the public cloud. And while we can't predict the future, what I can tell you is that thanks to our entrance into the public cloud, our ability to innovate has multiplied exponentially. Thank you very much.
Thank you, Roy. That was awesome, and it's really an honor to be working with Goldman Sachs, and we have learned a lot already from them, and you heard them talk about bring your own key. Just having the opportunity to collaborate with strategic partners like Goldman Sachs is one of the things we live for in AWS, so we're excited about the partnership and what we're doing together. So if you think about what people want in analytics, they really want to be using S3 as their data lake. They really want a broad array of analytics services. They want the right tool for the right job. And because so much of what we do is driven by what customers tell us they want from us, and we deliver frequently when we get that feedback, customers tell us a lot of things. And let me share with you one of the things that they're asking us for in the analytics space today. So if you think about it, most customers use S3. However, they store a lot of data and objects that when they're doing analytics, they only need a portion of the data in that object. So let's say, for example, you're a retailer and you have 20 retail stores, and every day you store all the sales data for those 20 stores in an object, and you do that every day. And then somebody comes to you and says, hey, could I get the sales data for the last 30 days for just one of those stores? Well, what you usually have to do is you have to pull out the objects for the last 30 days, all those objects, which have data from the 19 other stores that you're not trying to get analytics from, and then you have to extract just the data from that one store you're trying to get analytics for, and then you do your processing and analytics. So it's more time consuming that way, it's more expensive that way, and there's a lot of heavy lifting for applications. And people said, well, is there a way that I can just pull out the data that I want, just filter the data that I want to move faster and spend less when I'm doing analytics and my applications are accessing S3 as a data lake? So the team went to work on that, and I'm excited to introduce a new capability today, which is S3 Select, which allows you now to pull out only the data you need in objects from S3. So S3 Select dramatically improves the performance and reduces the cost of applications that are querying S3. And you really now can have the ability to pull out just what you need from those objects. And you can filter the data using standard SQL expressions like select and from and where. And this speeds up and lowers your cost pretty dramatically, in many cases up to 400%. Let me give you an example. So let's take a query here. It's going to be a Presto query, and it's going to be run against a standard TPC DS dataset. And that's TPC DS is a standard benchmark for analytics and SQL queries, and it's what everybody uses, except for Oracle when they make up their own benchmark the night before their keynotes. But everybody else uses TPC DS. And in this query, this is 6 subqueries with each containing a table, 3 aggregations, and 4 filters, where they're trying to pull out just what they need. So when they have to pull out the object as a whole, they run the query, and they get about 8 seconds, which is pretty fast. Then they use S3 Select to just filter the pieces that they need from that query. That same query takes 1.8 seconds, 4.5 times faster. That is a big optimization and improvement for you in time and in cost. You won't find that anywhere else. It's yet another reason why S3 is the best data lake solution for you. Almost all of our customers use S3 in some way, so we're really excited about giving this to you. Now, we've talked about S3 as a data lake, but one of the things that's interesting is that we have this other really large now storage service, this archival storage service called Glacier, which is storing a large amount of data, in part because it's an even lower cost option than S3. So if you have data that's not frequently being accessed, you want to move it to Glacier, and a lot of customers have been doing that. But one of the challenges with any of these archival storage solutions is it's just really, really hard to query. It takes a long time. You have all the same problems I was mentioning earlier around not being able to pull out just the data you want. And increasingly, what our customers have said is, we love S3 as our data lake, but we wish we could extend our data lake to also include Glacier, because we have so much data that we're storing in there. And so I'm pleased to announce the launch of Glacier Select, which now allows you to run queries directly on data stored in Glacier. So this is pretty unusual. You won't find archival storage solutions that have true querying capabilities, which you can now do against Glacier. And just like S3 Select, with Glacier Select, you can pull out just the data that you need, and then you can retrieve it using one of the 3 retrieval options that we have, standard or expedited or bulk, depending on what your needs are. And the important piece, above all else now, is that your data lake capabilities just got broader, because now it's not just S3, it's S3 and Glacier, which is super exciting. So we just talked about how analytics allows builders to have blind faith but no false hope, and how people want the right tool for the right job and what a fully capable analytics offering looks like. What about machine learning? How do we turn machine learning from a capability of the few into something that many more people can take advantage of? Let's see what our house band and Eric Clapton have to say about that. Now I know the secret, there is nothing that I lack. If I give my love to you, you'll surely give it back. Let it rain. That's what builders want with machine learning. They don't want it to be so difficult. They don't want it to be so cryptic. They don't want it to be black box. They want it to be much easier to engage with than it's been over the last, really ever. And you can understand why. Machine learning is so tantalizing for most everyday developers and scientists. The hype and the hope here is tremendous. And I think that you could argue, of all the buzzwords that we've heard in the 11.5 years that we've been doing AWS, machine learning might be the loudest, and it's absolutely the buzzword du jour today. And still there are a lot of constraints for builders, and we know this because we've been doing machine learning in a really serious way at Amazon for 20 years. And if you look at most of the things you see in our consumer business in Amazon, it's fueled by machine learning. If you look at recommendations, people like this product, also like this product. If you look at the pick paths that we optimize for robots in our fulfillment centers, if you look at what we're doing with Prime Air and the drones that we're programming, if you look at the natural language understanding and the short form automatic speech recognition in Alexa, if you look at what we're doing with the revolutionary concept of being able to walk out of a store without having to check out in a checkout line, those are all informed and fueled by machine learning and deep learning. And while there are thousands of people doing this at Amazon, you're also finding some of the more technically capable companies who are starting to use machine learning in a more serious way as well. And the vast majority of them are doing it on top of AWS. When you sort through all the hand waving and all the jumping up and down and all the noise, and you actually look at the number of customer references in ML, AWS is twice as many as anybody else. And if you look at the enterprise, it's 5 times as many. And there are lots of companies. These are companies like Pinterest and Intuit and Expedia and the National Football League and Zillow and Cerner and Stitch Fix and Yelp, Liberty Mutual, NASA JPL. Lots of customers are using AWS and machine learning, a lot more than you'll find anywhere else. And yet, I would argue it's still very early for most customers, especially mainstream enterprises, all of whom want to be using machine learning. And so we think about machine learning at a macro level of having 3 layers of the stack. The bottom layer is for expert machine learning practitioners. And these are people who are comfortable building models, tuning models, training models, figuring out how to deploy them in production and manage them themselves. And the vast majority of machine learning and deep learning that's being done in the cloud today at this bottom layer is being done on AWS on our P2 and now P3 instances, which are really, as I said, the most powerful GPU instances in the market today, and then using our deep learning AMI that we built that effectively embeds all the major frameworks. But we have a little bit different approach at this bottom layer of the stack than the other providers. We're not going to try and tell you that you should try and solve all your machine learning and deep learning problems with one framework. If you study the history of machine learning, the one constant is change. And so while today TensorFlow has the most resonance, and there's more TensorFlow being run in AWS than anywhere else, if you're trying to build a computer vision model, it turns out that Cafe 2 is often the best choice. Or if you're trying to build a recommender system or doing image or video analysis or natural language processing, it turns out that MXNet scales the best. We'll support them all. We will not tell you you can only use one or optimize only for one. We will always provide a great solution for all the frameworks and choices that people want to make. And there are a lot of them depending on what you're trying to build. And we'll do the same thing at the interface level. So we have a lot of people inside Amazon and a lot of customers who've started to use Keras over the last year and a half or so. And people like it. It's an abstraction that allows them to kind of not have to deal with as much of the framework muck. But one of the complaints that we've heard from builders is that when you build the neural networks in Keras, they're static. And so if it turns out that you need something different and you need to flex it, you can't do it. And it slows down your training. And so that was something that we wanted to fix for our own machine learning people inside of Amazon and for all of you. And we started working on it, and we started building something, and then we started to collaborate with Microsoft, who we found had the same challenges internally and externally. And together, we released into open source an interface called Gluon, which allows you to build neural networks that actually have the ability to dynamically flex if you decide you need to make changes. And then you also don't have to give up anything on training speed, given the way that we actually built it. So people are really excited about this. But again, it's this general principle we have that we're going to provide all of the major solutions that you want so you have the right tool for the right job. This is, Gluon, by the way, is available today in MXNet, will be in CNTK in the next couple of months, and the other frameworks next year. But while that bottom layer, you're seeing a lot of activity at that bottom layer, there just aren't that many expert machine learning practitioners in the world. We're training more of them at universities, but there just aren't that many, and most of them end up living at the big technology companies. And if you want to enable most enterprises and companies to be able to use machine learning in an expansive way, we have to solve the problem of making it accessible for everyday developers and scientists. Everybody's got a solution in this space, which we think of as the middle of the stack, but none of them have been easy enough for everyday developers. And if you think about it, when you're trying to build a machine learning model, it's not easy. There are blockers every step of the way. You need to first figure out how to aggregate all your data, and you got to figure out how to have some way to visualize and explore your data so you know what algorithms might be worth training. You got to figure out how to pre-process that data so the algorithms can do their work. Then you got to choose which algorithm and framework you want. And there are lots of choices. And the reality is, in the real world, the first algorithm you choose is often not the one that works. You have to try a lot of these, so that's a lot of work. Then once you choose an algorithm, you have to train the data. And even relatively small models consume a lot of compute. And to figure out how to reliably deploy that, it's hard. Most companies who do machine learning today have separable teams just managing the training environment. And then, if you can train the data so you have a promising model, you have to tune it and tune the parameters so you have a usable model. And it turns out, doing that tuning is quite difficult. There are thousands, and in some cases, in the largest model, millions of parameters that you have to tune. And you usually start off with something random, and then there's a lot of trial and error and a lot of hit or miss, and it takes a long time. And then, after all that, if you get a usable model, then you have to figure out how to deploy that model into production in a reliable way, which is a different set of computer science skills. And then you have to figure out how to manage that at scale and run the infrastructure. That's a lot of challenges just to build machine learning. And what happens is that everyday developers just throw up their hands in frustration. It's just too much work. I want to do it, but I don't have time to do all those things and have to do all that heavy lifting that's required in all those. And so, if you think about the history of AWS, we don't build technology because we think the technology is cool. Believe me, we are really excited about some of the innovations that we've built. You know, whether you're talking about EC2 or S3 themselves, or Aurora, or DynamoDB, or Redshift, or Lambda, or Snowball, and Snowmobile. I mean, lots of innovation that's come from AWS, but it's never because we think the technology is cool. The only reason that we build that technology is to solve problems for you, for our customers. And if you were able to read the original vision document that we wrote for AWS to propose the business internally, the mental model we wrote down was that we wanted to enable any developer or company to have access to the same selection of services, the same cost structure, and the same scalability as the largest companies in the world. And that's no different in machine learning. We want everyday developers and scientists to be able to use machine learning much more expansively. So with that in mind, it's my extreme pleasure to introduce Amazon Sagemaker, which is an easy way to build, train, and deploy machine learning models for everyday developers. So let's look at these blockers I talked about earlier and look how they're different. So you can prepare and store all your data in S3 in the data lake, and then use Glue to move that data from various places and do some of the transformations. And then right from the get-go, with one click, you get a managed hosted notebook that uses the popular open source Jupyter framework. And we have lots of notebooks that we've pre-built that you can use that are optimized for various use cases, or you can choose to import your own. Then, if you look at the stage of actually picking the algorithm, we give you a lot of choices, but that are much easier to implement. So you can either choose to use one of the Sagemaker algorithms that we have built and done all the work under the covers around the framework, or you can choose to specify your own or import any that you want. If you choose one of the Sagemaker algorithms, let me tell you what we've done. We've taken the top 10 commonly used algorithms, and these are things like k-means clustering for data segmentation, or you can use factorization machines for recommendations, or time series forecasting, or XGBoost. The top 10 of them, And then we've installed all the drivers and configured the framework for you, so you don't have to worry about any of that. And then what we've done is we've had separable teams working on each of these algorithms over the last number of months to optimize them such that 8 of those 10 algorithms run 10 times faster than you'll find anywhere else, and 2 of them run 3 times faster. And the way we've done that is that those teams have changed the implementation from needing to go back through data they've already seen and make multiple passes of the data to changing the implementation to be able to make one pass through that data, even petabyte in size. So much, much faster if you think about it. Now, if you don't want to use our SageMaker algorithms, you can choose to specify the framework you want to bring and the algorithm you want to bring with it. And we have done a ton of work over the last year natively optimizing TensorFlow and MXNet. So again, you don't have to worry about any of the behind-the-scenes setting up of the frameworks, et cetera. That's all taken care of natively for you in SageMaker. And, of course, if you want to bring a different framework, we're going to support all the major frameworks natively, like we have TensorFlow and MXNet, where we built it deeply into the SageMaker service. But if you want to use a different framework now or any algorithm you can imagine, it's really easy to import it. You just specify the location of the container in the Elastic Container Registry. This is a huge change in the ability to pick an algorithm and have a framework associated with it and to be able to run it. Then, once you've picked the algorithm, training is so much easier in SageMaker than it is anywhere else. And that's because all you do is you specify the location in S3 of your data and the instance type you want to use, including the powerful P3s, and in one click, SageMaker spins up an isolated cluster with its own software-defined network. It sets up auto-scaling for you, it sets up all the EBS volumes, it sets up the data pipelines, and it starts training either with the SageMaker algorithms or the TensorFlow and MXNet scripts or whatever algorithms you bring to bear. And then when you're done, SageMaker tears down the cluster. This is a huge efficiency gain in training. No longer do you need a separable team to manage the training. And then, if you've got a promising model, you want to make it usable and you need to tune, it's a really different experience in SageMaker than what you normally have to do. There's really 2 main things you have to do when you're tuning. There are 2 main choices you can make. One is, do I change the data that the models, that I'm ingesting in the model? And the second is, how do I actually tune the parameters, or what people call hyperparameters? And so as I mentioned earlier, today, that tuning of those parameters is largely random and takes a ton of time and trial and error. What we've done in SageMaker is we've built a feature called Hyperparameter Optimization, or HPO. And so with Hyperparameter Optimization, you can check a box at the beginning of tuning, and it will do that HPO for you. And what it does is it spins up multiple copies of your model, and then it uses machine learning to inform the machine learning model. So it looks at where, with each change we make across that parallelization of your models, which are having the impacts, and the model gets smarter, and it's much, much faster to tune those parameters. And by the way, again, you're tuning thousands and sometimes millions of parameters. So what it means for machine learning model builders now is that you don't have to worry about the tuning of the parameters. You just have to worry about, should I change the amount of data or what type of data I should infuse into the model. This is a huge weight off of builders' backs. And then, when you want to actually go deploy the model to production, all you do is you pick the instance type you want to use, the min-max number of EC2 instances, and you one-click your model to production. And SageMaker will deploy it across multiple availability zones. It'll set up auto-scaling for it. It'll set up the secure HTTPS endpoints so that it can easily connect to your application. And there you are. That's all you have to do. There is no other solution out there that lets you do close to this easy a deployment to production. Then additionally, we have the ability to allow you to do A/B testing. So you can test your new algorithm before you deploy it to production against your current algorithms or whatever your current method is of actually making recommendations to customers, which also is super useful. And then, when you got to go manage this thing at scale, once you're in production, SageMaker manages the compute infrastructure on your behalf. It not only does the auto-scaling, but performs regular health checks, and it handles node failures under the covers, and applies security patches, and does all kinds of routine maintenance, and all of this with CloudWatch monitoring and logging available for you. So one other cool thing here is that we built SageMaker in a modular fashion. So that means that if you want to build and train an algorithm, but run it in production somewhere else, you can do that. You just use the build and train capabilities of SageMaker. Or if you want to build and train an algorithm elsewhere and host it and run in production in SageMaker, you can do that as well. This is a big deal for everyday developers and scientists in machine learning, and this should make it much more accessible for customers. We're really excited about this. So, as we just discussed, SageMaker, I think, is going to make it much easier for everyday developers to build machine learning models, and yet still, people and developers are really interested in learning more about how they can use machine learning. They want to do it. And so they're reading all kinds of literature, and there's some code samples they can play around with. But I think for any of us who have had to learn something new that's got any kind of complexity, there's no substitute for hands-on training and application. And so we thought about what can we do that would allow our builders and our developers to get this hands-on training. And so the teams worked on this for the last year, and they came up with something pretty novel I think you're going to like. I'm introducing AWS DeepLens, which is the world's first wireless deep learning-enabled video camera for developers. So what this is it's a high-definition camera with onboard compute that's optimized for deep learning. And it comes with computer vision models that we've already built that you can use right on the camera. Or you can build your own in SageMaker and import them over the air via the console with a few clicks to DeepLens. It has Greengrass in it. So in addition to running the models, you can program Greengrass to run various Lambda triggers. There's lots of tutorials and pre-built models for you so you can get started right away. And in fact, we believe that you'll be able to get started running your first deep learning computer vision model in 10 minutes from the time that you unbox the camera. You can provide and you program this thing to do almost anything you can imagine. So for instance, you could imagine programming the camera with computer vision models where if you recognize a license plate coming into your driveway, it'll open the garage door. Or you could program it to send you an alert when your dog gets on the couch. Really, you can do almost anything. And it's going to give you an opportunity to, again, get exposure and learning very quickly in a way that you haven't been able to do before. And so to share with you a little bit more detail on how you can use both SageMaker and DeepLens, it's my pleasure to introduce to the stage the inimitable Dr. Matt Wood.
Good morning, everybody, and thank you, Andy. Amazon SageMaker takes away most of the muck of machine learning, making it easier and faster to build, train, tune, and deploy custom models. In this example, we're going to use machine learning to build a music recommendation service. To do this, we're going to get the play history from our users, we're going to apply an algorithm to it, we're going to optimize it, deploy it, and then based on what a user likes, we can make recommendations on the next songs to listen to. And when we've done all that, we'll have a little bit of fun with AWS DeepLens. So let's start by getting the play history from our users. You can spin up a fully managed and configured notebook in SageMaker running Jupyter, which is already connected to your data in S3. Notebooks allow you to quickly slice and dice your data to get it ready for machine learning. So here, we'll select from our play history dataset a set of fields we want to use to build the model. And now we're ready to start training. All you need to do is tell SageMaker about your training run, specify the dataset, and the training cluster spins up automatically, depending on the size, the memory, and the CPU and GPU usage that you need. SageMaker automatically provisions an elastic training cluster under the hood for your training. Now, we support any algorithm, including those running on TensorFlow and MXNet, along with common data science libraries such as scikit-learn and R. You can bring up anything else to the platform just by specifying a container of your choice. Now, while you can bring up any algorithm, a lot of the common algorithms which are in use today suffer from some pretty specific limitations. The first limitation is that they can be very slow to train. The second is that they are memory bound. That means that what can happen is you don't get to use all of your data to train your models. You get constrained by the memory, and you get constrained by the time it takes to train those models. So instead, what we do is we have made available 10 different algorithms on the SageMaker platform, which are designed to be 10x faster, 10x better than the currently available implementations. And we really started from a blank sheet of paper and designed these algorithms from the ground up, asking the question, what would these look like if we designed them to run natively in the cloud? So what we're going to run here is a factorization machine. And as you can see, what we do with the factorization machine, first of all, is we parallelize the model training under the hood. In addition to that, we're going to shard the data automatically and send it to the right models under the hood. So this parallelization and automatic distribution allows you to train your models much more quickly. The second thing that we're going to do is we're going to stream your data from S3 directly into the models. And as Andy says, we can train the majority of our models with a single pass over the data. And what this means is you're no longer constrained to running just models with training on gigabyte data sets, but terabyte, hundreds of terabytes, even petabyte data sets can be trained in a single pass by streaming it in there. So now our first baseline model is ready. We've trained across millions of rows of data, and we may very well be happy with the accuracy of this model. But it's very unlikely that we get the perfect model the first time. And so what we can do is you can tweak and fine-tune all the different parameters and all the different weights inside your model, and that affects the accuracy. Sometimes it's going to go up, sometimes it's going to go down. And SageMaker provides automatic model tuning, or what they call hyperparameter optimization. By changing the parameters of the model, you can change its accuracy. And hyperparameter optimization allows you to change those parameters, retrain the model, and then evaluate its accuracy. Now, this can be a very repetitive and time-consuming process. It's usually manual, and it can take just a ton of time. In SageMaker, we automatically run multiple fine-tuning runs in parallel. And we actually use machine learning to evaluate the weights of all the individual models. And here we're not just looking at the accuracy of the model, we are iteratively selecting interesting features from the different models and incorporating them into the next iteration and the next optimization run. And we go over and iterate again and then again and again, and our models become much more feature-rich. They're detecting more features in the data, and their accuracy increases as a result. So from here, we can select our best performing model. And now, with a single click, we can deploy this to a fully managed, elastic, fault-tolerant, multi-availability zone cluster, and we'll run the model behind a friendly, easy-to-integrate API. So now with a single API call from our app, we can make fast, accurate music recommendations for our customers at scale. There's no muss, there's no fuss. SageMaker removes all of the undifferentiated heavy lifting associated with machine learning so that you can focus on getting the absolute best models and all the ideas that go along with it. OK, so what we think is going to happen once you get this capability is you're going to be able to train dozens and dozens more models. This stuff gets really addictive really, really quickly. Because it's so easy to train new models in SageMaker, you can use all the data that's available to you to do whatever you like. Let your imaginations run wild. You're no longer constrained by the muck and the heavy lifting. You're now able to use all of your data and optimize those models quickly. And so you can come up with all sorts of wonderful ideas built and trained inside SageMaker. So continuing the theme of music, we could train a deep learning model to recognize the album name just by looking at the album art on the cover of the record. Or we could do some simple face recognition and detect smiles and frowns. Now, one of the things you'll appreciate as you go through this is that you're really experimenting with machine learning. And that's probably the best way to learn and build your skills. To continually refine and invest in your own education is one of the biggest things that we can do as developers. And it's really this inspiration that led us to create AWS DeepLens, which is the world's first deep learning-enabled wireless video camera specifically built to help developers hone their skills with machine learning. You can train these up in SageMaker. We'll deliver them down to the device. So DeepLens runs the models directly onto the device. The video doesn't have to go anywhere. They can be trained in SageMaker and deployed to the model. So I'm going to do a quick demo here over on the demo podium. I have a couple of DeepLens devices set up and ready to go. We have one on a tripod right here. You can see it for the first time. It's small and compact. And what I'm going to try and do is I'm going to try and do a couple of live album mini reviews. So we've pre-deployed the models that we talked about before, the identification of albums based on the album art, and facial recognition and facial sentiment analysis, and those are running directly down onto the device. So I'm going to try and do a mini review with one of my all-time favorite albums. So you can see Dark Side of the Moon detected with a positive expression. Next, I'm going to try an album which I'm not quite so fond of. So we correctly identified Whenever You Need Somebody by Rick Astley, and then we correctly identified my negative expression. So we can now take these mini reviews. Because the video never has to leave the device, we can just send up the metadata to our recommendation service, which is already running on SageMaker. So we can send that up to the device and spit out some new recommendations using the model that we just trained. So here you can see Eric Clapton, the Rolling Stones, and Fleetwood Mac. Not too shabby. So I want to close out this demo on a word about availability. So at the conference this week, or today and tomorrow, we'll be running a series of deep learning workshops. They're focused around teaching the fundamentals of machine learning using computer vision, using the DeepLens devices. And if you attend one of these workshops, which, as I say, run from today to tomorrow, you'll walk out of those workshops with a free DeepLens in your hands. You guys are going to love them. Additionally, anybody that attends a session in the machine learning track or at the Deep Learning Summit will get an opportunity to get a free DeepLens, which will ship early next year. And we're taking pre-orders on Amazon.com starting today. We can't wait to see what you're going to build with DeepLens and SageMaker. Let your imaginations run wild. And with that, I'll hand it back to Andy. Thanks a lot.
Always illuminating, Dr. Wood. Very interesting, and you can tell that we're really excited about giving these capabilities to all you guys. So far, we've talked about the bottom and middle layers of that machine learning stack we talked about. Let's talk about that top layer, which we call application services, which really are artificial intelligence that emulate humans' cognitive abilities. Last year at reInvent, we launched a text-to-speech service called Polly. We launched a conversational app capability called Lex, which is really all of the natural language understanding and automatic speech recognition in Alexa wrapped into a service called Lex. And then we also launched an object recognition service called Rekognition. And what this service does is it allows customers to be able to add image analysis to their applications. So you can ask questions like, show me a picture where there's a woman driving. Or you can ask a question like, is the person driving smiling or frowning? And loads of customers are already using Rekognition. One of the cool examples that's relatively recent is there's an organization called Marinus, which is working with law enforcement agencies to help solve human trafficking. And they have used Rekognition to analyze millions of photos and still shots and advertisements to try to match facial recognition and faces with the faces of the people they know are missing. And already, in just a short amount of time, they've identified and recovered several people who were victims of human trafficking, which is really cool. So in addition to object recognition and facial recognition, the service is able to tell you, it's able to recognize inappropriate content, it's able to do celebrity recognition, it's even able to do image text recognition, so you can look at words, static words in street signs or in advertisements like Pinterest is using us to do. And people really love this image recognition service and recognition. One of the things that people have asked us is they said, well, this is great for objects and images. Can you do the same thing for video? Now, that's a harder problem because with an image, end to end, that's what you gotta, the image is the thing. But with video, you gotta deal with time and motion. And very often, you need the context of the frames before and the frames after and knowing exactly what you've captured. So it's not a simple problem. So we've been working on this for a while, and I'm excited to introduce for you a new service called Amazon Rekognition Video, which does real-time and batch video analytics. And so with Rekognition Video, it lets you pass videos to us using our, the APIs or an SDK we provided, and we'll detect all sorts of things in the video. We detect objects and faces and scenes, like a package being arrived, which is useful for a lot of different apps. And then we'll also detect inappropriate content that you may not want up on your website, videos that you may not want your users to be watching on your website. It does celebrity recognition, and then it has a really cool, unique feature that you won't find elsewhere called person tracking. And so a lot of times what you see is that a person is in the shot, but they're blocked from the camera, or they're out of the frame. And using technology called skeleton modeling, we're able to track a person even if they're not in the shot and know whether they're still in the frame or not. And that's really useful. When you think about the types of applications people are building and will build, you can imagine an application where all of the systems are accessible in a room if you know that one person's in there and they shut down if that person's gone. And having that person tracking will allow you to be able to be much more accurate in your applications that you build on top of the service. So video recognition is really easy to use. As I mentioned, you just use the APIs of the SDK. It can handle millions of videos that you've stored in S3 through the batch processing we provide. Unlike anywhere else, it handles real-time video, which is really important for the types of apps you want to build. Like I was talking about earlier, if you want to be able to open your garage when you recognize a license plate, or if you want to be able to know when your dog has jumped on the couch. The service will automatically timestamp everything it identifies, so it's easy to find and locate and use with your applications. You'll also see that the service will continue to get better every month, but just because of the sheer volume of video content we have internally as well as through publicly available data sets. And then as with all our services, we're going to make this available to you in a very cost-effective fashion. So the people we've told about video recognition have been super excited because they love doing image recognition and recognition. But they've said, well, that's great that I can do now video analysis, but how do I get all the video into the cloud? That's a pain in the butt. And in many ways, this is similar to the conversations we were having 2 or 3 years ago with people who said, okay, I get it. I want to be in the cloud, but how do I get my data in the cloud? And it's part of what caused us to build things like Snowball and Snowmobile and Kinesis Firehose and things like that. And the problem is, if you think about all the videos out there, they exist in all these disparate types of devices, whether it's video cameras or cameras themselves or phones or satellites or radars. And there's a lot of diversity and a lot of standardization and a lot of normalization and a lot of work you have to do to be good at taking that video in from all those devices. So you could build a video ingestion service. It's hard to do. It takes a lot of resources, but you could do it. But I don't know why you would if we're going to provide something. So introducing the launch of Amazon Kinesis video streams, which securely ingests, stores video, audio, and other time-encoded data. So just like Kinesis for data that lets you ingest and store data, Kinesis video streams does the same for video and other time-encoded data like radar. And so it provides SDKs for the device manufacturers to install on their devices. It makes it easy for them to stream this video to AWS. And it also durably stores, encrypts, and indexes data streams, along with providing an easy-to-use API so that apps can access and retrieve these video fragments or tags based on timestamps. And then one of the things that we've done is we've deeply integrated Kinesis video streams with video recognition. And so what that means is you have an easy way now to stream all of this data from devices, all this video into AWS, and then you can immediately start to be analyzing it with video recognition, which is pretty cool for builders. So that's the vision part of those application services. How about language? You know, I talked earlier about the fact that last year we launched both Poly and Lex, but there are so many other things that builders want to do with language. And one of the things that's been interesting is that there's so much data now that's being locked up in audio and video files. And the problem is, practically, it's kind of impossible to really search audio well. And so the best way it's turned out to be able to capture this and to do something with it is to convert it from audio to text. Traditionally, how people have done this is that they've hired manual transcription agencies, and they're expensive and they're time consuming. And so what people typically do is they really only pick out the very most important things they want to transcribe, and they leave all the rest on the table. All this data and all this value is sitting out there, not being taken advantage of and leveraged. And so we'd like to change that for people. So I'm excited to introduce a new service called Amazon Transcribe, which does automatic speech recognition. So Transcribe does long-form automatic speech recognition. It can analyze any WAV or MP3 audio file and return text. It's super useful for all kinds of things, like call logs and subtitles for videos, or capturing what's said in a presentation or a meeting. We'll start with English and Spanish, but we'll have many more languages coming in the coming weeks and months. And then one of the things that we do with this service, which is different from other transcription services, is it won't show up to you as just one long uninterrupted string of text like you'll find in other transcription services, but instead, we use machine learning to add in punctuation and grammatical formatting so the text you get back is immediately usable. And then we'll timestamp every word so you can align subtitles to the right video, and that's much easier to deal with. We'll not only support very high-end video, or very high-end audio, but because so much of the audio today is locked up in phones, you have to be able to deal with lower quality, low bitrate audio, and we'll support that as well here. In the future, what you'll see in the coming months, you'll also be able to distinguish between multiple speakers, and then you'll also be able to add your own custom libraries and vocabularies, because there are certain words that you may use in a different way than others that you want the service to understand so it can be used quickly the way you mean it. Now, Transcribe lets you transcribe long-form audio files into text. But most of us have customers all over the world who speak several different languages. And so what you want to do is you want to take that transcribed audio to text and translate it into a lot of different languages. And again, the way that people have traditionally solved this problem is that they've hired translation agencies, which are expensive and time-consuming. They only pick out their most important pieces to do, and they leave all that value on the table. That's another thing we want to help you with, so I'm excited to announce another new service called Amazon Translate, which automatically translates text between languages. So Translate is great for use cases that require real-time translation. These are things like live customer support or business communications or social media. And you can translate an entire bucket at one time in our batch operation, so it's very scalable. You'll see in the coming weeks, We're going to be able to recognize the source language on the fly, so you don't even have to specify what language you're trying to translate from. And again, like all our other services, you will find this to be very cost effective. So, new services from us to transcribe audio to text and then to translate them across multiple languages. That's really useful. But one of the things, if you're thinking about it, is, well, now I'll have a much larger corpus of all of this text, and I won't know what the heck is in this text or what it means. And there aren't easy ways to figure that out. You could have people manually try and go in and look at what these things, actually mean or what the sentiment is, but it's going to take you a long time to do that. In fact, you'll never come close to finishing across all that text that you're going to end up storing in S3. And you can imagine all kinds of things you want to know. You can imagine customer service interactions. You want to know if they're positive or negative, or you can imagine all kinds of social networking posts about your company, your product, where you want to get a vibe quickly about whether or not people are digging what you have or you don't. It's super useful. And typically how people try to solve this is, as I said, either manually, which doesn't work out so well, or they try and figure out if they can use natural language processing in some fashion. But it's hard to do on your own for all the reasons we've talked about already. So the team has worked really hard on this, and I'm pleased to announce another new service called Amazon Comprehend, which is a fully managed natural language processing service. So without ever having to provision a single server, Comprehend can understand documents and social networking posts and articles and really any other data in AWS. And you simply provide the data that you're storing in your data lake in S3 via the Comprehend API, and then Comprehend uses natural language processing to give you highly accurate information about what it contains in 4 categories. Entities, which are really people and places and dates and brands and quantities. Key phrases that add significance to the language, what language is being used, and then sentiment, whether or not people are feeling positively or negatively about that content. I'll give you a practical example, it's pretty cool, which is Hotels.com, which is an entity of Expedia. They have thousands and thousands of customer reviews and comments on the various hotels that people have used their site to stay in and what they liked or didn't like. And today, before it just looks like this big blob of data. It's really hard to pull out what matters and doesn't matter. And so they're using Comprehend to understand what are the unique characteristics that people really like about each hotel, whether it's that they have a great dinner menu or great bathroom features or whatever it is, and what do they not like? So that when they're making recommendations to their users, they have the right way to differentiate and distinguish each hotel so people can make the right choices for themselves. The other thing that Comprehend has, which you won't find anywhere else, is the ability not just to look at a single document at a time, but to look at millions of documents in order to identify the topics within these documents. It's something that we call topic modeling. And it's incredibly useful if you think about it. If you're a publisher with thousands of articles, it makes it easy for you to use topic modeling to figure out how to show just the business articles to the customers you think are interested in business, or just the political articles to the people you think are just interested in politics. Or if you're a healthcare provider, you may want to group all of these documents based on diagnosis or based on symptoms. This is a much easier way to understand what is in your data and then group them in a way that you can actually display and use that's useful for your customers. Comprehend does this in an incredibly efficient manner. Just to give you an example, if you tried to take 300 documents, each about a megabyte each in size, Comprehend can build a topic model in just 45 minutes for $1.80. That is incredibly useful when you think about it, and completely changes the meaning that you can get from your content. So what's required to have the broadest and easiest to use machine learning platform that the most number of customers want to use? And I think that sometimes people get confused on this, and they get so enamored with the machine learning services that I just spent several minutes going through, and several that we launched, which we're really excited about as well. But they forget that if you don't have the right foundation, it doesn't really matter what your machine learning services are. And it means that you have to have an incredibly capable, reliable, secure, saving you money, fully featured data lake like we have in S3. And it means that you need to have all kinds of security and access control capabilities, because a lot of this data is going to end up being your crown jewels. And you need to have the right compute and GPUs, and again, you won't find a more performant GPU instance out there than the P3 today. And you need to have that broad array of analytics services that's going to work well with what you're doing with machine learning. Then, when you have that foundation, you can layer on top of that deep investments in each of those 3 layers of the stack that I talked about. And it's not just having the broadest array of frameworks and interfaces for you to have the right tool for the right job, and not just the application services I just went through over the last few minutes, but importantly, it's making it so much easier and accessible for everyday developers and scientists to be able to actually engage in, get value out of, and use machine learning. And if you look at the capabilities in those 2 columns on the screen right now, nobody has the combination and collection of capabilities that AWS has. And it's why we have the broadest and most capable machine learning platform, and why you see the most number of customers who are using AWS for machine learning. Now, one of our customers who are using AWS for machine learning is the National Football League, which is one of the most revered and most watched brands on the planet. And they have all kinds of interesting things they're doing, but one of the things they have is this app called Next Gen Stats, where they're able to track ball movements and player movements and change the way they are able to view what's happening in the game. And so to share a little bit with you about how the NFL is using AWS for machine learning, it's my privilege to introduce to the stage the Senior Vice President and CIO of the National Football League, Michelle McKenna-Doyle.
Hi, I'm Michelle McKenna-Doyle, Senior Vice President and CIO of the National Football League. I'm responsible for the league's technology strategy, which includes making sure we leverage the best and greatest in new technologies to evolve our game, engage our fans, and protect and develop our players. For those few of you who might not know about the NFL, we are America's largest sports organization with over 180 million fans worldwide. We're a big content creator, creating 15 of the top 20 broadcasts in 2017 alone. But I'm here today to talk to you about a technology that we're very excited about, Next Gen Stats, also referred to as NGS, all powered by AWS. You may have seen some of our NGS content online or even in broadcast. It's our player and play tracking initiative that is aimed at evolving our basic stats that we've been collecting since the game began manually to an automated fashion of gathering thousands of data points and creating new stats and new insights. We do this in all 31 venues in the US, as well as the venues that we play in London and in Mexico. In 1 week of games, we create about 3 terabytes of data. And for you techies out there, that's probably not a lot. But for us, it's more than we've ever collected since we began to collect stats in 1920. We now collect in 1 week of games. Now let's take a closer look at how it works.
The NFL's Next Gen Stats platform is changing the game, giving broadcasters access to real-time location data, speed, and acceleration for every player, every moment, and on every square inch of the field.
A twisting, diving catch, touchdown!
Sensors throughout the stadium track tags placed on players' shoulder pads, charting individual movements down to the inch.
The Next Gen Stats have been credited with 968 yards of running tonight in total.
During the course of a game, broadcasters now have instant access to how much distance a player covers and the speed on a particular play.
A big man can run 19 miles an hour.
along with receiver routes and acceleration.
You look at that speed.
In the NFL, the future is now.
Pretty cool stuff. Behind me, you'll see the framework of our NGS data. And I just spoke to you there in the video a little bit about what the capturing part is about. But in the center of this slide, that's the heart of the system and the heart of the program, all powered by AWS. We first started playing around with this a couple of years ago, and we chose AWS then because of its flexibility, ability to scale quickly, provide the right level of security, and also, as you've been seeing through this, the broadest offering of cloud services that our builders could build upon, giving us the ideal platform with which to grow. The next step is then to distribute this across to the end users, all real time in under a second. And we focused on two main audiences for distribution when we started to think about this. First of all, for media, used in-game, it's used in live games, and it provides nuggets of data for input, analysis, and showing on the screen. Post-game, for all those football experts that want to talk about what happened, how, and why, that's great content for them. And of course, digital and social to engage our fans, bringing them closer to our players, and building on our storytelling. Obviously, too, you can imagine what this could mean for scouting and coaching. We do have a tool within this program that uses next-gen stats to record every play and automatically produces play diagrams, fitness summaries, relative speed and distance of our players, and also heat maps that show where players are on the field at any point in time. This allows for some really deep analysis even over and above what's done today. Our officials, as you can imagine, they're also instrumented. They cover more field service in a game than any player on the field. We also want to make sure they're in the right place. So using those heat maps and the analysis that we gather, we can do official analysis. And then finally, in venue, we do love the fact that the best place to see an NFL game is in the stadium, but we also know there are things you get to watch online and offline that you might not see in a stadium. So we're pumping this data also to the game presenters and making sure they're sharing it with fans in venue. As you can see, AWS is a big part of what we're doing here, and it's the critical foundational component of our next-gen stats, and it's been powering it since the beginning. So as such, I'm very happy to announce that our relationship with AWS is expanding. AWS is now an official technology partner of the NFL for next-gen stats. With AWS, we want to unlock the full potential of our next-gen stats through this broad cloud solution and something we've just been talking about, machine learning and artificial intelligence. As you can imagine, this program is about collecting massive amounts of data, complicated data sets, and then boiling it down for insights. So machine learning and AI are important to us for two main reasons, probably the same as many of you. First, efficiency. We've been gathering data manually. It takes hours at a time to do this post-game analysis and route analysis, you'll see. We'd like to boil that down to quickly and make it available right away. And again, to enhance the fan experience. Give the fan the ability to understand and comment on the game, maybe at the same level a coach or some of our talent on air is able to do. Why AWS for machine learning and AI? Well, as our experience has shown us so far, it has the broadest and deepest functionality. It's easy to use, and it's proven technology. That's why anyone would like to go with any technology provider. But we know we're just beginning to scratch the surface on this, and taking something so complicated and something, frankly, that we're all figuring out, it's great to have a partner like AWS to be our enabler for the future. So let me walk you through real quickly for some examples of how we'll be using or taking our next-gen stats to the next level. First of all, around formation recognition. There are 35 basic routes in the game of football across offense, defense, and special teams. But within those formations, there are thousands of combinations based on who's on the field, what the matchup is, and even factors like what time of day, or if it's an evening game, or where it is. So who knows the types of formations that could come about. We want to classify these and be able to recognize them and analyze them real time. Route recognition. There are about 9 basic routes. So if you coach football or play football, you probably know what those are. But within those 9, there's about 50 advanced routes. They can get complicated and hard to recognize and to draw out, but with machine learning, we're hoping to be able to recognize that and be able to record it. And another key component of machine learning is what are the key events that drive these things. And so by identifying these key events, recording them in the right time, we can create things like QB efficiency and QB quality around how long they hold the football before they throw it, how long it took for the wide receiver to catch the ball, what degree of separation they got against their defender, etc. So applying machine learning to our data will start with us, very much as you were just hearing. It's all about that learning model. First, we need to train the learning model, take all the data that you traditionally think about, the traditional stats, down, distance, etc., combine it with other data elements like field condition, weather, things that right now might not seem to the human mind even correlated. Feed that into Amazon SageMaker, let our model learn, and then begin to pump in additional information, have it trained, test and adjust, and ultimately the goal is to automatically generate all the formations, routes, and events. Here's a real-world example of what we want to build with AWS, which we think will change the way fans experience and understand football. Here's a play of Tyrod Taylor completing a pass to Andre Holmes for a first down. At first glance, you can see that it looks like a simple routine pass and catch from an untouched quarterback to a wide open receiver. But we're interested in understanding is why was that play successful and how can we quantify it, both for real-time discussion but post-game analysis as well. So by taking a look at some key events here, I'm just going to call some of them out. This is a little bit of a football lesson. We want to produce things like what the offensive formation is pre-snap. This is called a trips left, so you see the blue circles there. Those are the receivers. You can also see what the defending team did. So they matched all the receivers with what's called a 6 defensive back formation. And you can actually see that key matchup down below between Andre Holmes and Darryl Roberts. So this is an interesting way to think about, well, we know Roberts is going to cover Holmes, but what route ultimately was run? This shows the big major routes, the yellow one being the post route that was actually completed. And then the key identifiers, we take all of that plus say, okay, when was the ball snapped? When it was passed? When it was caught? And ultimately when the tackle was made. This can all be fed into, take all that data. So why would we want all that? One reason would be to get new insights and things like the pre-snap read. Here we're showing probabilities of success. If you throw to Andre Holmes here, you've got a 60% chance of a completion, and that's based on a bunch of factors that we've fed in. So that's the most ideal target for that pass. Then you can take a look in mid-play, a snapshot of all the catch probabilities. This is important because when you're talking about your quarterback the next week and everyone's doing what is called Monday morning quarterbacking, but now you just won't have to wait till Monday morning, it can be right away, we can see how good the decision making was for a quarterback. So imagine a coach being able to tell him, look, you made a bad decision on that, or vice versa, the player can say to the coach, hey, this is why I took a sack, because these probabilities were so low. So together with AWS, we're very excited about the future. We want to take this technology journey together to have a lasting impact on America's game. We're developing and preserving it for generations to come. Thank you.
Tom Petty, may he rest in peace, surely didn't realize when he was writing that song back in 1981 that he could have been talking about getting data from IoT or edge computing devices. But he was. The reality is that trying to get data from these edge devices is really hard and really painful. And it's frustrating. I mean, if you think about, just think of an example like an airplane, and when it has a part that's about to break, It's so much faster and such a better customer experience and so much less costly if you can do that preventative maintenance because you know there's a problem than if you wait for it to break. It's rough having to wait for that data, and people are frustrated because it makes them move slow. It turns out that waiting for all that data is indeed the hardest part. And if you look at what's happening in the world of connected devices, it's kind of amazing. There are millions of devices everywhere, in your homes, in your offices, in factories, on planes, in cars, in ships, in agricultural fields, in oil fields, everywhere. And inherently, these devices have relatively little disk and relatively little CPU. So it means they disproportionately need the cloud to help them. And in fact, if you look at most of the big IoT implementations today, they're all being supplemented by AWS. And whether you're talking about Illumina with its genome sequencing hardware that's hooked up to AWS for analytics, or John Deere, which has a couple 100,000 telematically enabled tractors that are sending real-time planning information back to AWS, which is doing analytics and sending that information back to the farmers. Or whether you're talking about Major League Baseball and Fox, if you see StatCast, that's a big old IoT application that's running on AWS. Or Enel and Engie with their smart meters. Or BMW, which is doing, taking sensor data from cars and dynamically updating their map information. All of these companies are using AWS to help supplement these IoT implementations. And when we think about where we are in the adoption curve of IoT, I think I would argue of all the buzzwords of choice over the last 11 and a half years that we've been working on AWS, I think IoT might be actually delivering the fastest in terms of actual number of companies doing real work there. And I think some of that has to do with device manufacturers are excited about this, and people are excited about getting data from their own assets. But still, I would argue, despite all that, we're now just entering a world where the growth of the number of devices is going to be exponential. And so a lot of what we're thinking about in enabling this next phase of IoT is how to enable people to manage all those devices at scale. So I'm going to talk about a few frontiers that we're trying to help solve problems for you. The first is just getting into the game. I mean, there are many companies who've built IoT apps that do really interesting, complex things for customers, like smart meters with Enel and Engie. But there are a lot of people who say, look, I have a really simple use case I want to provide for IoT. I want to be able to allow you, as a customer, when you want the dishes to be picked up from room service in a hotel, press a button and have that trigger a Lambda function, have them pick up the dishes. Or I may want, every time you pass by a particular tool in a factory, for that sensor to recognize that and issue a verbal warning about using that tool. Simple, straightforward Lambda triggers that they want to get into the game with. And so we're announcing today the launch of a service called AWS IoT One-Click, which really is one-click creation of an AWS Lambda trigger for any device. And this really works pretty simply. Once you register your device and selected the device you want to build a Lambda trigger for, you can choose from a whole bunch of pre-built Lambda functions that we've built, or you can import your own. You click on it, and you're done. You have a Lambda trigger. It's really that simple. It'll help a lot more companies to start using IoT. The second frontier we're thinking about is device management. If you think about it, as you're starting to expand the number of devices in your fleet, it's a lot of work. You have to onboard and provision all of these devices one by one. You got to monitor and query devices to see if there are any problems and then take corrective action if you need to, again, largely one by one. And apart from being time consuming, it's hard. You can build your own, but again, it's going to take a lot of work. And you can stitch together third-party solutions, but none of them really do it end-to-end, so you often end up with gaps in compliance and security. So that's something that we wanted to try and help solve for you, and I'm excited to announce a new service today called AWS IoT Device Management, which securely onboards, organizes, monitors, and remotely manages your devices at scale. And so what this allows you to do is it helps you onboard and deploy new devices in bulk with one click. You can deploy thousands of light bulbs to multiple locations, really with one click. While you do it, you can onboard and provision your 509 certs. It allows you to maintain an inventory of all the device information that you need, like manufacturer and serial number or firmware version. That then allows you to kind of query along those dimensions and see where you need to troubleshoot. And then, if it turns out that you actually have to troubleshoot, you can manage these devices in bulk, you can do it remotely, and you can do updates over the air on your entire fleet, on part of your fleet, or on an individual device. You get to choose, but this makes it much, much easier to manage your fleet of devices if you have a number of them. How about security? For most of us, for sure with AWS, security is the #1 priority. You drop everything if you believe you have an issue there. And IoT is still, though, a relatively new medium. And I think a lot of us remember about a year ago the DDoS attack on Dyne that took down big chunks of the internet. And when they went and did the investigation, what they found was it was a number of connected devices that just weren't locked down right. So it's something that all of us need to be thinking about as we're deploying large numbers of devices. Now, AWS IoT Core, which is our core IoT service, allows you to pretty simply handle the security for a single device. But again, when you have lots of devices with a lot of diversity, that's much harder. And so we're pleased to announce a service coming in early 2018, which is called AWS IoT Device Defender, which will define and enforce security policies for fleets of devices. And so, as I mentioned, it's pretty straightforward to handle the security of a single device. But when you're managing large fleets, it's much harder. And so Device Defender does a few things for you, a couple things in particular. One is it audits and monitors your entire fleet of devices for adherence to stated security and compliance policies or best practices. So it allows you to tell us, here are some of our compliance policies, we want these to be adhered to, or we have 14 best practices policies that you can choose to use, and we'll alert you if one of them isn't being met. So for instance, you can imagine, one of the best practices is not sharing certs across devices. And you could imagine somebody's, putting a new device online, they accidentally use the same cert as somebody else. Device Defender will catch that and alert you to that so you can fix it. Or you may have a stated policy that I don't ever want a certification in use that's going to expire in less than 30 days because you want to risk that it'll expire before you catch it and it'll bring your application down. Device Defender can alert you to that as well. And the second big thing that Device Defender does is it monitors your entire fleet for abnormal behavior that might indicate a potential security issue. So Device Defender lets you effectively tell us what is your expected behavior. What ports do you want open? Where do you expect traffic from? Where do you want to send traffic to? And then it'll let you know if something is off. If there's a port open that shouldn't be open, or if it looks like you're sending data to a malicious IP address, or see some kind of spike that might be a DDoS, Device Defender will alert you to all of this. So this will be a big step forward in handling security of lots of devices. How about analytics? When you think about analytics at the edge, it's not your normal analytics. It doesn't take structured data. It isn't normalized. You're trying to deal with data that comes from devices that are often in motion. And there's all kinds of intermittent connectivity for these devices, so you often find corruption or gaps in the data. It's hard to deal with. And in fact, a lot of the signals you get back when you're trying to do this analytics, it's hard to make sense of it. And so this is something, again, that we took a lot of time thinking about because we have so many customers who want to do it. Now, one of the things that's interesting is we have a partner in C3 IoT that has done really sophisticated, clever analytics for a lot of our IoT customers. But a lot of people have said to us, can we just have the basics? We just want to do basic analytics so we can get going understanding what's happening on our connected devices. And so today I'm excited to announce the introduction of AWS IoT Analytics, which is a fully managed analytics service that cleans, processes, stores, and analyzes IoT device data. And so AWS IoT Analytics is fully integrated with AWS IoT Core. It's pretty simple to use. You define an analytics channel and select the data that you want to actually store. And then it ingests the data, and you can configure it to enrich or filter or transform the data. You know, one of the problems, if you think about the problems with some of these connected device data, is that it often needs other data to make it useful. So take a vineyard or producer. They may want to measure constantly the humidity of the soil to know whether or not they actually need water. But if you only took that data and you didn't enrich it with anything else, you might actually go water it when it's about to rain in 2 hours. So you want to take that humidity of soil data and enrich it with the predicted rainfall so you can take actions and decisions that make sense for your business. So you can configure AWS IoT Analytics to enrich your data. You can do transformations. You want to transform from Celsius to Fahrenheit. It lets you build conditional statements and do message filtering. And then you can store that data that's enriched and filtered and transformed, what we call process data. And you could also store the data raw in case you want to actually do another round of enriching and filtering and transforming later that's different. And then we give you an easy built-in query engine to answer basic business questions that you want to answer, including being able to support sophisticated analytics like k-means clustering and statistical inference and linear regression. Again, a very different type of analytics service that's going to give you the ability to do core analytics on your connected devices. How about smaller devices? This is a really interesting issue that people often don't talk about, but which is a huge issue if you think about the future of connected devices. All of the connected devices today that are using the cloud and that are able to take action on data they're getting on the actual device are devices that are big enough or expensive enough to house a CPU. But the reality is, the vast majority of devices out there aren't big enough to house a CPU. Instead, they have a microcontroller unit or an MCU. And the number of MCU units outweighs the number of CPU units by 40 to 1. These are devices like smoke detectors or soap dispensers or most light bulbs, they're innumerable. The vast majority of devices today are not connected to the cloud because even though these MCU devices have an operating system inside, and the one that's used the most is FreeRTOS, those were built at a time when people weren't really thinking about the cloud, and so they can't leverage it at all. That's a problem that you really have to fix if you want to enable most devices to be connected to the cloud. So we've worked on that for the last year or so, and I'm excited to announce a new operating system called the Amazon FreeRTOS, which is an IoT-connected operating system for microcontroller-based edge devices. This is pretty exciting. It's easy to use. If you have an existing device, you can just download Amazon FreeRTOS from our console. We already have an array of supported microcontrollers with companies like Texas Instruments and NXP Semiconductors and STM Microelectronics and Microchip. And then what we've done is it's really FreeRTOS that we've extended with a number of libraries that make it easy for you to connect your MCU devices to the cloud. And so what it lets you do is it lets you send data from these MCU devices to AWS, set triggers where you want to take action on those triggers in AWS, and then send the information back to the MCU units. Same way the CPU units are able to leverage the cloud today, which is, again, something that hasn't been the case forever. And then, for our customers who have these smaller devices where they don't want to make the round trip to the cloud, or they don't have connectivity to make the round trip to the cloud, they're able to still be able to take action by connecting with a Greengrass device that they have nearby. And Greengrass, again, is effectively a software module that we built that lives inside your device that has Lambda on board, so you have the same programming model on device or in the cloud with Lambda triggers. And so what you can do is Amazon FreeRTOS is integrated such that you can send messages to a nearby Greengrass device, have it look for those triggers, those Lambda triggers that you set, run those triggers, run that code, and then send directly back to the MCU units, which again is pretty groundbreaking and different than what's existed the last bunch of time. There's all kinds of capabilities built in now to do security and credential and key management. This completely opens up what is possible for the number of devices that exist today to be able to be connected to the cloud, get data from their devices, and take action on it. We're really excited about it. So the last two songs that you've heard from our amazing house band are Eric Clapton's Let It Rain and Tom Petty and the Heartbreakers' The Waiting. Or what we talk about, the waiting is the hardest part. And so, what are some similarities there? Well, both are amazing artists. Both have really good voices. Both are really good guitar players. Both have had beards at different parts of their life. But another connection between those two is that builders want to let it rain and have access to machine learning at the edge where the waiting is the hardest part. And we have had scores of customers ask us, how can we actually enhance on top of what you're already doing at the edge where we can actually run the machine learning models right there? And so we thought about that and we worked on that, and I'm excited to introduce the preview of Greengrass ML Interference, which lets you run machine learning models and inferences at the edge. Today, as you know, and as we talked about earlier in the machine learning part of the talk, the normal way that this is done is you have to build these models and you do all this work and all this training and all this tuning and deploy it, and it's all done in the cloud. But there are a lot of customers who have these devices where they want the models they've already spent all this time building to just spit out the predictions at the edge on the device itself without any latency going back to the cloud. And that's what ML inference in Greengrass is going to enable you to do. You can use a whole bunch of, we have a bunch of models that you can use yourself, but of course, I think what most people will do is use Sagemaker to build these models, and then you'll be able to send them, again, over the air to the devices so they can make these inferences and these predictions at the edge. Again, a huge enabler to connect the ability to run machine learning at the edge. So I'm going to close going back to that parenthetical from the Lauryn Hill song, Everything is Everything, and talk about after winter must come spring. And that lyric, if you think about it, is really about the inevitability of change. And I think it's very applicable to what's happening in the technology space today. We are going through the biggest transformation in technology in our lifetimes with this transformation to the cloud. I've had countless conversations over the last several years with lots of people asking, how long do we think this transformation is going to take? Some people think it's going to take just a few years because look at the incredible pace that's happening already. Some people claim it's going to take a few decades. I also have had conversations with a number of people who know they need to think about and know they need to care about the cloud, but in reality, they're not that interested. They really kind of want to be doing things the same way they've been doing it for a long time. And they have a number of old guard technology companies who it behooves for this transition to go really slowly in their ear saying, that's okay, you can do that. It's going to take a few decades. They are not helping you. They are not helping builders. The reality is when you're making a big transformation like the cloud is, the longer you take to make it, the harder it is to execute because you get deeper and deeper into the hole, whatever you're building or what you need to crawl out of. This is not about skating to where the puck is, guys. The puck's been dropped and it's right in front of you. And you got to decide, are you going to play or are you going to skate away and not play? And I think for companies, there is a huge penalty for not playing because you're going to have less capable technology than all of your competitors who are leveraging the cloud. And there's going to be so many technology advances and capabilities that we put out there. Remember, we're launching 1,300 services and features this year. That's on average 3.5 new capabilities a day for you to be able to take advantage of if you want. You're not going to find that if you're not using the cloud. And so does anybody in this room believe that the next 10 years are going to have less innovation than the last 10 years? I don't think so. And I think the last 10 years have had a lot of innovation. So this is a time to be building. There is so much to invent. There is so much to change. There's so much you can do for your customers. And unless you're a monopoly that doesn't have competitors, all of your competitors are going to be using the cloud. So this is the time. It's a golden age in computing. Go out there and change your company, change the customer experience, and we'll be there every step of the way to help. Thank you very much, and I hope you enjoy the rest of the conference.